Hello.
Good afternoon, Professor Longo. I am Hebe from Tampai. Can you hear me now?
Yes, I can hear you. How are you?
I'm fine. This is 4 p.m. at your time, right?
Yes, it is.
How was your day?
Good.
Actually, we have been following your research since Tampai was founded, and it is my great honor to meet you face to face today.
Oh, thank you.
As we have introduced in the email, the Longevity Forum we hold annually is aiming at bringing up the top scholars around the world in these fields like you to discuss the latest researches, interventions, and technologies and transform it to our Chinese audiences. So it could be said that it is our most significant event annually. It is really appreciate that you would like to record the lecture for us in advance. That supports us a lot.
Sure. Happy to do it. Yeah.
There is another thing that I want to make sure with you that we have collected some questions about longevity diets from our followers in advance. It would be great if it is convenient for you to answer them.
Sure.
Well, if it is not, we may discuss it in a follow-up
No, it's
email.
fine. I can answer them.
Thank you so much. Now, may I start it now? Shall we start?
Yeah, you can start. Yeah, let me first load up, share my screen. Okay. Yeah, I'm ready to go. Okay, so thank you. And I'm Dr. Longo from USC, University of Southern California, School of Gerontology, Longevity Institute. And so my laboratory is focused on nutrition and longevity, but also the genetics of aging. And so why are we studying aging? Well, we're studying aging because obviously it's a very interesting, scientifically interesting topic. But also, I was struck by this slide by my colleague, Matt Chamberlain, on the risk factors for cancer, heart disease, and Alzheimer. And you see smoking and obesity keep coming up as a number, among the most important risk factors. But then they almost disappear when compared to 30 years of aging, right? So now, even smoking and obesity, which we've heard about for so long, being so central to our being unhealthy and our diseases. But now compared to aging, they're not insignificant, but very low effect, right? So then, of course, we want to, fight smoking and reduce obesity, but also the most important thing is going after the aging process. So, I mean, the health span is something that you heard about. And so it's not about how long you live, but it's also how long you live healthy. But then I cloned a new word, which I felt was missing, which is Juventology, right? So the study of, not just the study of aging, what happens during the aging process, which is called gerontology, but the study of how do you maintain somebody young, right? So, and that's what I call Juventology, the study of youth. And that's as important, I think, as health span. So is there a program that keep people young for a longer or much longer time? Or can we modify that program, to make it go from, let's say, 40-year program to 60-year program, maybe 70 years program? Can we keep people young for 60 years instead of maybe 40 or 30 or 40? Okay, and so if you look at the aging field, you see stories like this one, and this is Madame Calment. She has the record longevity, so she made it to 122 years of age, and she smoked until 117. So she did not have a healthy lifestyle. But probably, as you see from her, and also from other people that I followed, for example, Emma Morano, who made it to 117. And I studied her for the last 5 years of her life. And she did not have a good lifestyle. But then she had brothers and sisters, all of whom made it to age 90, 95. One sister made it to 102. And so that's probably the genetics. So these are very rare individuals that can do whatever they want. And they still, if they're lucky, it comes with some fortune. But if they're lucky, they can make it to a very old age, independently of the lifestyle. But for everybody else, I think we know now very clearly that the nutrition and dietary restriction can make a big difference. So this is probably the most ambitious study ever done in the world for longevity, which is let's follow monkeys for their entire lives. So it's a 25-year-long study. And these are monkeys that have been studied at the University of Wisconsin by Richard Weindruck and Rosalind Anderson and Dr. Calment. And so what happens if you take a fairly westernized diet, but you just give 25% less? So in one group, you give a normal level of a Western diet, and then another group, you give the same exact diet, but 25% less calories, right? So you cut it by a quarter. And the results are striking. So diabetes or insulin resistance went from 60% on the normal diet to 5% on the 25% calorie-restricted diet. Tumors were reduced by 50% by calorie restriction, and cardiovascular diseases were reduced by 20 to 30%. But there's also and this is when Walford, actually, this was my mentor back many years ago, 30 years ago, when I started my graduate school. And Walford did his own study of calorie restriction in this Biosphere 2 area in the Arizona desert. So the idea, actually 8 people went inside of this Biosphere 2, and there Walford was a professor at UCLA, started the first human calorie restriction study that lasted almost 2 years. And in this study, they show a reduction in the risk factor for cancer, heart disease, diabetes, hypertension. So this actually happened before the monkey study, but so I'm presenting it after, but it happened before. So now similar results, right, from the monkey study and the human study. And now since then, the human studies, many studies have followed this, and they confirm the calorie restriction is very powerful in reducing disease risk factors. This is just some example. This is when they enter Biosphere 2, they have a fairly low blood pressure, and this low blood pressure becomes even lower in the people that are calorie restricted, and then they exit Biosphere 2 and it goes back. Glucose levels, they start from 90, they drop to about 70. Cholesterol level, they start at 185 total cholesterol, and it drops to 125. So it's really revolutionizing the risk factors in these people. But if you look at Walford on the left, is Walford when he was in calorie restricted, and so he doesn't look healthy at all, right? So he looks like he's being pushed over the limit. So he's getting very low cholesterol, very low blood pressure, very low glycemia, but he's doing it at a cost, right? So it's too much, right? It's now moving into a dangerous range to get it. And here is Walford normally after he exited Biosphere 2, and he was very healthy, had a very healthy nutrition. So he went from very healthy to maybe too much, right? On the left during this Biosphere 2 stage. So is it possible then to get the benefits of this intervention, calorie restriction, without changing your diet? And so for years and years and years after the Walford laboratory time, I started thinking, what if you just fast a person for 5 days, and then you allow him for maybe 1, 2, 3 months to go back to the normal diet, whatever it is that diet is? Could that 5 days carry their effect for months? And originally this was done for cancer. We developed what's called a fasting-mimicking diet. So we were looking at a nutrition that will last 5 days that will be equivalent to water-only fasting, right? So this is low calorie, low sugar, low protein, high fat, plant-based, 100% plant-based diet. And we were looking at effects on IGF-1, IGF-BP1, glucose, and ketone bodies. These are markers in the blood that tell us the person has entered, or the mouse has entered, a full fasting response state, right? Just like if they were not eating at all. So they get to eat, but they have the effects that they will get by not eating. And so what if you take a mouse that is genetically, now we're going to the worst of the worst. This is mice that are genetically engineered to develop diabetes, right? And they become very big, obese, morbidly obese, and then they become insulin resistant, and then they start dying from this insulin resistance, right? So what if you take these mice, and then you start the cycles of this fasting mimicking diet that I just showed you. And these are 5 days, in this case, every couple of weeks, right? So what happens? Well, what happens is if you start the cycle, you see that the glucose level comes down and the survival stays 100%, right? Even though these are mice that are condemned to be obese genetically and condemned to get diabetes genetically, almost 100% of them get it. But the most interesting thing was not about the type 2 diabetes, but was about the pancreas and the regeneration of pancreatic cells, right? So here you see the red is insulin-producing beta cells in the pancreas. You see after we give them this toxin called streptozotocin, the insulin-producing beta cells go down after 5 days, and after 50 days, it's still all green, right? So there is no insulin being produced in the pancreas of these mice. But if we start the fasting-mimicking diet, we see that now the pancreas is able to make new beta cells. So it's beginning to generate new functional insulin-producing beta cells. And this appears to, these C3 lanes, this is when mice eat a normal diet. And this is where the fasting-mimicking diet, and this is 1 day after refeeding from the fasting-mimicking diet. And these are embryonic pancreas, the embryonic developmental genes, right? So they're the ones turned on when the pancreas is generating, when the mouse is first born. And you see that all green, it means they're all shut down, right? So they're normally shut down, but in the fasting-mimicking diet, they turn on, right? And during the refeeding, they're still turned on. So there's a lot of these genes, right? So it looks like the pancreas is beginning to act like in a mouse, it would in a mouse that is first born. And so is undergoing a developmental phase that is leading to functional beta cells. So then Amrenda, and this was Chao Wei and Valentina and Roberta Buono in the lab. Now, Amrenda Mishra instead took on a different task a few years ago, which was, what if I take mice and I give them a very bad diet, a very bad Western, high-fat, high-calorie diet? And so, of course, these mice become obese and they live short, right? So what if once a month, for just 5 days, I switch them to a fasting-mimicking diet that I just showed you, the same one that we gave to these diabetes mice? And so the results are pretty striking. You see that on the high-fat diet, the mice become very large, and these are the control mice, and these are the high-fat diet plus 5 days amount of the fasting-mimicking diet. And if you look at fat, you see that this is the high-fat diet, lots of fat accumulated, lots of body weight accumulated, and the fasting-mimicking diet reversed this. But then if you look at lean body mass, no change, right? So we're reversing, with the fasting-mimicking diet cycles, we're reversing the accumulation of fat, but not affecting the muscle mass. And also, if you look at cholesterol, high-fat diet, the cholesterol goes high and very high when the mice become old, and the fasting-mimicking diet cycles, just 5 days a month, are able to reverse this effect. And also, when you look at the entire lifespan, now you see these are the mice on the normal diet, these are the mice on the Western diet, and these are the mice on the Western diet plus 5 days amount of the fasting-mimicking diet. So the fasting-mimicking diet is able to almost completely reverse the negative